gum out in case I spit it out during the...
You have enough space right now.
Yeah, I've got plenty, actually.
Good morning. Testing. Why is that? It's not very loud, is it? Can you guys hear me okay on the speakers? Okay. So good morning, everybody. If you guys want to come close, we're going to have a very unique discussion around diagnostics of the HVAC equipment that we have now, we're going to have in the future, and we had in the past. And we have a great panel here with us. We got Aaron Longacre from Testo, Nick Stokovski, did I say that right? From
Stokovski.
Stokovski, sorry.
Usually everybody gets that one, so.
From Inficon, and Gerry Wagner from Tosot. And a lot of knowledge up here, and we're going to do this in a way where we're going to go from the past to the future in HVAC diagnostics. So, I mean, Aaron, you work for a manufacturer that's very progressive in digitizing and connectivity and all that kind of stuff. But 30 years ago, none of this stuff existed. We used analog gauges, we used analog scales. Everything was basically analog, and it wasn't necessarily as accurate and as efficient as things are today. So let's go back 20, 30 years ago and maybe how things have progressed to now. What were your thoughts on how we did it 20 years ago?
I mean, the best thing was that's about when I started in the trade about 20, 30 years ago at this rate. And I remember learning the whole analog way. And, the nice thing with learning the analogs, you actually had a good baseline at that point in time to learn. Digital tools started to come into the industry, and it just basically kind of gave you a whole, wow, look at this. Why is this different from what I used to do before? The whole beer can cold, all those different ways. But looking with the accuracies of digital, as quick as you can be in the field, because we now know you have to be quick because time is money, money is time. So it's definitely been a big learning experience, I think, for the industry as well as the manufacturers to making sure we're developing things for the technicians as well that meet the demands as well as are super accurate and can give you those results right away.
Nick, would you agree that back in the day, I say back in the day like we're old or something, but I mean it was back in the day when I first started. It was a set of analog gauges. It was literally an analog scale with a dial on it it took like literally 30 seconds before it would actually rest and tell me what the weight of my refrigerant tank was. Now we're in this era where we get this information super quick. So in the past, I mean, do you think we were doing our job as efficient as we could be doing it today?
In terms of efficiency, I mean, I think technology has definitely helped speed things up. When you start talking about the ability to track what you've done, the jobs that you're going to, versus writing everything down on paper even, the ability to job log, things like that have really helped guys stay organized, stay efficient, even with alarms and different technologies that way. You can kind of do multiple things at once, and you might be able to pay attention to a few different things at one time. So where you really had to pay attention before, now you can kind of handle multiple things at once with new technology.
Correct. You can multitask because there's technology doing things behind the scenes that you don't actually have to eyeball once you trust that technology is actually working in your benefit, right?
Right. Even, when we tie that even to leak detectors, right? With some of the the technologies that we have now and the methods that we can use, it's different going from a halogen torch, right, obviously, to an infrared, or even using the ppm that we have with the Stratus. Those are all things that have progressed from years of watching people do what they do and seeing how we can develop and make their jobs a little easier and a little faster.
Yeah, for sure. So Gerry is a world-class trainer. I mean, if you guys have a chance to go to Gerry's training class for Tosot, it's amazing. And I just told him, I promise you won't fall asleep. He'll make you sign a hug waiver maybe, because you might get a hug from Gerry during his training. You will get a hug. So, Gerry, I mean, in your class, like I came a couple of years ago and I did a 3-day course with you, and I was just blown away by your course and how you commanded the floor. I mean, you almost turn into a different person. Like there's a character within you that trains. And what I found about your training was you're very progressive in your thinking when it comes to technology. And it was maybe the opposite of what I maybe thought that how you would teach things. So maybe talk about why you've adopted the technology sort of realm within your trainings to help technicians sort of get better and efficient on their job sites?
Yeah, sure. Well, first of all, let me just start out by saying, Aaron talks about 20 years ago, him starting. Well, I'm the one guy on the panel that started 40 years ago. So, so I am analog biologically, right? So I have seen the progression literally over 40 years in the trade. And talking what Nick had mentioned, when you asked him about efficiency, I would quickly just add to that, Nick, no, it wasn't efficient by any stretch of the imagination. One of my rants in my class, in my installation class, is evacuation. I have come to the belief that for generations now, we have been improperly evacuating, but to no fault of our own, because no one told us that we need special instruments for this. We looked at an analog gauge and we saw it went into a vacuum and we said, this is great, man. I don't have
it
to
hit
buy
30 inches of mercury and it was like, let the refrigerant
yeah,
fly, right?
All I need is a vacuum pump and I'm going to town, And another thing about efficiency, Nick, what is one of the probably two main reasons why it's not done correctly? It takes too long. Right? And time is money, Aaron,
Yes.
right? You said that. Right, so with new tools like things that NAVAC is putting together, these evacuation kits, Yellow Jacket with the Super Evac manifold, you're doing it correctly in half the amount of time. Come on, even an old guy like me is going to get on board with that.
Okay, so that's a good point, evacuation. That is one of the things that has really progressed through the test of time. We know we need to pull a vacuum, a good one, but there's been a lot of things that have changed over the last 20, 25 years. I mean, our 22 systems, they had mineral oil, right? It didn't grab moisture like POE oil does. So we need to keep that in mind when we're pulling a vacuum. One of the things that probably wasn't done very much back then was a decay test, right? And we have apps now to track stuff like this with our micron gauges that connect to our phone or our tablet. And I don't think enough technicians even know what a decay test is, never mind performing one. I mean, we get to the point where we're at 500 microns or below. I mean, that's always been an industry standard, but I think 500 microns, to be honest, is old school nowadays. It should be, if you can get below 250, do it. But the whole thing about holding it there after your evacuation is done is really important, because, I mean, you could have a micron gauge on a system set up in your manifold, but if you don't shut your pump down and valve it off, you don't even know if it's actually 500 microns until you do that and watch it rise. So maybe let's talk about a decay test for a minute and how the tools and the technology has helped us pull a better vacuum.
Absolutely, and even with making sure you have the right pump, you also have the right hoses, you've got limited connections. Your sensor as well, too. You have absolute pressure sensors in a manifold, but then there's a different sensor in a micron gauge, so making sure that that's correct. But, to the point of getting down to that lowest point, you also want to make sure, and Gerry, I'm sure you know from this teaching, is that you might get down to that target, run that decay test, and maybe 20 minutes you're up about 200 microns. You might still have more stuff in there because we know we've got tons of turns in there. We've got tons of issues, maybe issues or not within the compressor. You might pull some more moisture, some more foreign matter in there. So yeah, sometimes you might have to run it twice, maybe 3 times to make sure you're getting everything out. It's just like trying to pull something through a small door. So you're going to pull and push until it comes through. Same thing with a vacuum or with an evacuation.
Nice. Okay, so Nick, what do you think about the whole transition to, we're going to pull a vacuum, but we're not going to do it through gauges. We're going to avoid restrictions. We're going to pull cores. We're going to use large diameter hoses. And when we're done, we're going to perform our decay test. With the whole heat pump thing, we got to remember, heat pumps in cold climates, they're outside the outdoor unit. So if we have moisture outside, it could freeze in small cap tubes or in valves, whatever. And that's the last thing you want, is any moisture freezing outside because you didn't pull a proper vacuum. So the decay test is super important because of that. Even if we just use that example, it's super important.
Yeah, no, and I think that some of what even some other manufacturers are doing to help with the decay test, to kind of, when you talk about people don't know how to do that properly, well, if we can handle that from the manufacturer side to say, hey, and look at it a few different ways to say, okay, if we can show you or guide you through this, we can make sure that you do it properly to eliminate any of those
exactly.
variables.
And that's where I think in Canada here, these guys that are in the trade, they're all going to school. They're all doing a 5-year apprenticeship. But we need to instill the trainings that are beyond that license, micro training, stuff that Gerry does. Even a 4-hour class on a Monday afternoon or something like that. These little and small trainings, they might seem like they're a waste of time, but the amount of stuff you learn and keep up to date with is incredible. So Gerry, like transitioning to large trainings into these little micro trainings that happen periodically through a year, do you think that's maybe like a good step in the right direction to keep us up to date on what we're doing here?
Yeah, no question. And, one good thing that came out of COVID was the webinar.
Yeah.
Right? And don't get me wrong,
agree.
I'm not a fan of webinars as a trainer because I get no energy as a trainer from webinars. But that said, it kept me employed through COVID, so I appreciate the format. But now, it is that micro training, I think, as you describe it. That's a great way to describe it. It's just a good way to keep your head and your hands tuned, so to speak, and it can be done at your leisure, right? At home, at your office, on a phone. So no question that the micro training, I'm going to use that, Gerry, from now on. It's a great...
I didn't coin that term,
No, okay.
but
Yeah.
someone else did, and I
copyright
love
on
the
that.
phrase because that's what it is. It's a
mine
micro
now.
training. Yeah.
It's helped us from a manufacturer side too. To when you see somebody using our tools and we come up with something new, that's a little
Just go
different.
closer to the mic.
Yep, that's a little different. It's nice to be able to have access, easy access. I mean, we can't be everywhere at once, and we try to reach these guys, from a technical training aspect. And so when we can put some of this stuff together, some of these trainings together, and talk to somebody that's 6 hours away and guide them through what some of the issues their company might be having, and it might be just stem from the original training that we had, we can reach them a little easier. So webinars have been really helpful for us.
Yeah, for sure. I want to take the conversation to leak detection of refrigerant. It could be natural gas, propane. Again, the old school method was, okay, so we're going to remove the refrigerant because we might not have enough pressure in the system, and then we're going to pump it up to 200, 300, 400 psi nitrogen, and we're going to take our soap out, and we're going to coat everything with soap. I mean, not really an efficient way to leak check a system. If you've already got refrigerant in there, refrigerant leak detectors have come leaps and bounds over the last 10 to 15 years. Back in the day, there could be a lot of false positives. If you rub it against the wrong, it's going off, and people were losing trust in them. They're not like that anymore. Let's talk about leak detection as far as an electronic and then using a liquid detector like soap to sort of back up your findings afterwards instead of soaping everything right off the bat.
Yeah, I mean, you think of soap bubbles, that's time consuming. You got to mix it up. You got to go along your line. If you have about 60 feet of line set with maybe 8 or 10 different turns, different 90-degree joints, that's a lot of time there. With a leak detector like what Inficon has, I mean, obviously we have them as well. You're just going down the line, you're getting it, and you're starting to kind of pinpoint where that part is. Now, is it on the bottom, is it the top? You can use that to try to figure out just to have that range where it is. But I think that cuts down the time dramatically. Yes, it is a little bit of an investment, but I think the time savings over the time of checking for leaks definitely is worth it from that perspective.
100%, yeah. So, Nick, I know that you got something to say on leak detection. I mean,
No.
as far as being efficient, I mean, soap is still a good tool if you're using the correct soap. And you can't go to Walmart and buy Dawn. You got to use soap that is designed to microbubble. Like, you want that microbubble, that foaming action that only some soaps that are designed for the HVAC industry can do. Shameless plug, Big Blue from Refrigeration Technologies is designed to microbubble and foam up so you can see the tiniest of leaks. But sometimes the soap won't reveal it in a timely manner. So that's where the electronic leak detector comes into play, and it just picks it up so quick, right?
Yeah, definitely. And the way that we kind of state this is we find it with the leak detector, with the electronic leak detector, and we verify with the bubbles, and that's kind of how we go about it. And again, leak detectors have come such a long way from even in the past when we talk about going off to a wide range of gases to now we've got infrared, a very narrow band window where we can look at specific refrigerants. But a side note from that is the difference in just having a consistent tool, right? Where a heated diode degraded over time and didn't really tell you whether, what the status of your tool is. You can go through and have a whole, let's say, you can go check a whole area, but if you don't know how well your tools are operating, so again, the future is we can tell you that, right? And we can keep you consistent, and we can make sure you're doing the job the same way every single time.
Yeah. So I want to pose this question. I want to bring this up to you, Gerry, and get your thoughts on it. I do some refrigeration, and I come across a lot of evaporators and walk-in boxes that are just starting to corrode away because of the food. They're not sealing it. There could be fruits, vegetables with acidic off-gassing, right? And it starts to eat away at the coils. The problem with trying to soap a coil that has formicary corrosion, basically the copper walls are so thin, we're leaking through the pores of the copper. You may not see that with bubbles. And I have literally taken a leak detector and shoved it underneath the evaporator coil in a walk-in cooler, and it just goes insane, right? And then I'm like, that coil is done, right? So this is one of the reasons why I love using an electronic leak detector on jobs, especially when you have evaporator corrosion like that.
Yeah, no question. I mean, me being the oldest guy on this panel, I grew up in the day of soap and water, right? But even I have moved on from that. You mentioned the refrigeration technologies, which I have to try because I love refrigeration technologies. I'm a Nylog guy, you know that, right?
Yeah.
But my favorite leak detection solution is by New Calgon. I think they call it Cal Blue or New Blue, something like that. I use that on a VRF system. Imagine the amount of fittings on a VRF system. It found the most tiniest leaks in the hardest spots. By far, these solutions nowadays are so much better and so much more efficient and will detect the tiniest leaks. So, again, we have to move forward.
Yeah.
I just recently, some guys turned me on to a heat paste, a heat absorbing paste, right, instead of the wet rag.
Yes.
And refrigeration technologies, I love, has a product called Wet Rag. Come on, you got to love that shit. But it's just, we have to move forward, right? No question.
Okay, so let's move to diagnostic of refrigeration equipment when it comes to pressures, temperatures. Analog gauges, yes, was the go-to. And I mean, I remember when I got my first set of Testo gauges and I was showing them online, it was basically getting laughed at, right? Like, oh, those are a gimmick. Those are a toy. Now, I mean, everybody and their brother that wants to do their job efficiently is looking to, or has them, or looking to purchase a set to try them out. Some people have legitimately tried them and said they went back to analog, which is fair. I mean, that's their preference. But most people, they find that once they hit that digital side and they see all the readings on one screen in real time, changing quickly, screenshots, apps that create spreadsheets and all that kind of stuff, they just find it makes their job so efficient. So, I mean, we got probes now, too, and probes is, to me, the way of the future where everybody's trying to get rid of the manifold. Every person you talk to in the trade that has an opinion, is high up in education, they're trying to rid of the manifold for a few different reasons, and probes seem to be the future. What do you think?
Agreed. Yeah, I definitely agree. And a lot of the sensors that are in the digital manifolds are the same sensors that are in the probes. Yeah. The only thing is you're cutting down what you got to carry. Yeah. Because I know from one of my technicians at my father's company, he was always saying, all I need to walk into a house is a clamp meter and a 6-in-1 to at least diagnose 90% of the system. The nice thing with the manifolds and even the probes is you've got that software backing. You don't need 3 different kinds for all the different refrigerants because they're geared differently. They've got their plus and minus 3% on the accuracy side. These digital manifolds and these probes have all your refrigerants already in them, 90 plus that we have, and all those calculations and everything that's all done in the background is all done, through your phone and even the manifold as well. And then on top of it, if new things come about, new refrigerants that we are starting to see, like the A2Ls, and I'm sure at some point we're going to see A3s at some point, you're going to have those refrigerants that the companies are starting to develop that are getting better and better with the GWP. Those can be updated to the firmware and then also the algorithms in the back end. So instead of going out and buying a new set of analog gauges all the time, or even get a new set of, something smaller, you got probes and you got manifolds that are all set and ready to go.
Yeah, and I guess, Nick, I'm going to pose you this question. It seems that there's software out there, there's maybe not software, but tools we can use that we can hook up to equipment now. There's equipment that's already coming pre-packaged with this stuff on it that actually gives us this pressure temperature relationship. It gives us our superheat and subcooling. That's a high-end piece of equipment. Not a lot of people are going to buy that equipment right now, I don't think, but in 10, 15 years, it could be like a backup camera in a car. It could just be stock. It could just be part of the equipment. Do you think that is coming where one day, and I know that's not good for manufacturers that make digital tools and stuff but one day could we see equipment already outfitted with all these diagnostic tools on them?
Yeah, I think that's a pretty natural progression, because if it is helping that much, even from the manufacturer's side, even the warranty side, right? If somebody can have access to some of what you're doing, they might be able to see what's going on remotely, right? And help you
and
go
void
through.
your warranty right off the bat. Yeah.
And void the warranty. But honestly, even on the leak detection side, they have all. You can use some of those same tools to even try and investigate a leak that's happening, right? Well before that, you might be able to find it with a fixed detector somewhere. So even on our side, we're starting to see where more advanced tools that it can be integrated on the systems help, even in our world on the leak detection side.
So I want to jump in on that.
Jump in. I got a question to piggyback that, but you jump in.
Because at this point in my career, coming from the manufacturing side with the Tosot people, our onboard diagnostics blow me away. Yeah. But something I always say to guys who come to my classes: don't surrender your talents and your skills to a computer.
Yeah, that's correct.
Put a frickin' gauge on it. Validate, confirm what the system is telling you, the diagnostics are telling you. I'm impressed with it, but at the same time, I'm impressed with my Chevy Silverado telling me when I got a tire going down. I don't know how the hell it knows, but that's pretty cool. But these systems, and again, I think it is a natural progression, Nick. I think there's no doubt that equipment is going to get more sophisticated and have more data requirements, and also be able to give us more data. I see it with my own equipment.
Yeah.
One thing to add to that is think of our customers too. You can Google and find anything these days and get your answers right away. And believe it or not, I think some of our customers are getting smarter than some of us technicians just because of what the information that's available to them as well. And I'm sure you see it all the time, Gerry, when you're out in the field. So it's also just doing all those checks like, looking at this and doing all these other things. Hey, there's definitely a problem here. You may have an idea, but, I'm the certified guy taking a look at this.
Last night I was talking to a guy that is big on electrification, he's big on it. And he had a bunch of stuff installed in his home, and it wasn't installed right. So, and he's not a technician. He opened up the manual and started fixing things, right? And I'm like, just open the manual and it's all there. So he doesn't understand what happened with the installing company. But like you said, the information is there for everybody. It can be dangerous at times because that information in the wrong hands can be dangerous to the homeowner, to their home if they burn it down, or they could get hurt. It is what it is. We can't do anything to avoid that. You trying to jump in there?
Well, I was going to say that, the flip side, when you talk about efficiency, getting the right data to you, I think in this day and age, we have a lot of data. It's figuring out how to harness the
Sift
right
through the
data.
BS, yeah.
Right.
Yeah.
And so that's even from our side. It's like, okay, how do we deliver the most valuable data to you without clouding up your job and making you less efficient, doing the opposite.
But guys, I witnessed something incredible this morning before I came to this table. In the opposite end, the opposite corner of this hall, there is a skills competition going on with young techs who have never installed a heat pump before, and that's what they're doing. And guys, I saw them reading manuals, printed manuals. How cool is that? I was like, wow.
I admit I'm still a printed guy.
Somebody actually reads them.
I mean, here's one thing that that we talked about yesterday is there's a lot of manuals out there that need to get up. So we're talking about present and future of HVAC diagnostics, but that's also the method of how we do things. Some manuals, you open them, and they're like, it's still like we're doing things 20 or 30 years ago. Like any ductless split manual I've opened in the last, I don't know, 5 years or so, is showing you to pull a vacuum through a set of gauges, right? So, I mean, I think that we need to start updating the information as well that we're putting out to the technicians so everybody's kind of on the same page.
Well, I'm going to let you in on a little...
Is the Tosot manual
well, here's an industry secret that I'm going to expose right here in front of everybody. You guys all know that most of the inverter systems come from the Asian countries. Let's be honest, whether it be China, Japan, Thailand, Korea. And the manuals are being written in those countries. And therein lies, quite frankly, the biggest part of the problem. There's translation issues at the very least. Again, they're using analog
and they don't
equipment.
have access to some of the things that we have here, which is very unfortunate. I get messages all the time, where can I buy that? Where can I buy that? And I give them a website, and they're like, well, I'm in India or I'm in here, and they can't get access to these tools. So how do we help these people in these places get access to the tools that we have so they can do their jobs better as well, right?
Well, again, I think that with the manuals being weak, and I'm just painting that with a wide brush here, but with the manuals being weak, in-person training.
That's right.
It's self-serving.
Come back to that.
In-person training is
back.
the way to go.
Come back to that. Okay. I mean, what else can we talk about here as far as diagnostics and how we're progressing? I mean, airflow. Airflow is another one, right? I didn't know what total external static pressure was until a few years ago, because in the land of commercial service that I was in, nobody cared about it. In residential, it's a lot different. It seems to be, because a lot of ductwork is undersized in residential applications. And I've started to pay close attention to this. And it's amazing how many pieces of equipment have an oversized air handler and undersized ductwork. I don't know how it happens. Like, is this stuff not put to an engineer before it goes into a subdivision, before they build it all? My house is a disaster when it comes to airflow. Yeah. The front of my house is amazing airflow. The back of my house, it's like a fart in the wind. It barely gets anything, right? And my temperature rise across my furnace is already high, so I can't even balance. I can't close dampers down. So, I mean, total external static pressure, airflow, that's a big one that's coming into the future of diagnostics as well.
It is, and especially being able to make sure that these units can be efficient is important, because I know, for example, my house, I've got a tiny, I think it's a little 2-ton Goodman that's in my house, and yeah, in the summertime, okay, great. It's, it's cool downstairs, but upstairs tough, so I'll do the balance, but still there's a lot of issues that are trying to get all that up there because of the way the house was built and the way it was designed. I think the biggest thing is with COVID, obviously, the biggest issue we had was availability of air conditioning units. Yeah. And I remember hearing the stories like, well, we're back ordered for another 6 months and couldn't get anything in. So I think at that time, we had money to spend. Technicians want to get these jobs done. So it's like, okay, well, we'll put this in here, but not taking a look at that duct work. So I think that's where now it's like, after all that cycle has gone through, seeing that total static pressure and just doing those testing, and at least even training technicians even how to do it, I think is the biggest thing, because I still think there's a lot out there that don't quite understand it. When you think of pressure, you think of pressure in a ball, a tire, or anything else. You don't think of it as in your ductwork or in your house, because we also got to keep in mind our house breathes as well too with the drafting and everything.
Yeah. So I'm going to put this question to both of you guys, or not quite, more of a statement. So people that nerd out in HVAC and static pressure and all that kind of stuff have come to the conclusion that if you're hitting 0.7, 0.8 inches water column in your total external static pressure, that's when the ECM motors start to degrade and fail, because we've basically ballooned the duct, the pressure's too much, and we're not moving enough air. We got onboard electronics in an ECM motor. These electronics need airflow to keep them cool. So if we've reduced the airflow, how do we keep them cool? And if you talk to some people, they'll say 0.7, 0.8. If you hit that or anything above, that ECM is going to be done very, very shortly. What do you think about that scenario, that statement?
Yeah, I mean, I think everything has its design conditions, right?
Yeah.
And if you exceed what they're meant to work in, you're going to degrade, any piece of equipment.
Yeah. So working for a manufacturer, and is this part of your training, Gerry?
Well, it's not, Gary, because, again, my background coming out of the boiler industry and then ductless, unitary systems, airflow, it ain't my gig, and I admit that, right? But I tell when I do classes on our unitary product, our inverter unitary product, I tell guys, someone in this equation, someone in your company, someone in your distributor, has to be putting a ductilator to this thing, has to be applying some science to this thing. We have to be sure we're getting at least 350 CFM per ton, right? If it's a new construction, this ductwork has to be sized to that. If it's existing construction, you have to be sure that if it's a dual fuel system, the furnace can provide that. And to be honest with you, who knows if that's actually happening, but that's the scary part of it.
That is the scary part of it. There's a lot of companies, contractors out there that literally lick their finger, put it to the wind. They size the equipment this way. They walk into I had a call from somebody, and they wanted a ductless in a hair salon, and the guy says to me, yeah, I need a 2-ton. I go, how do you know that? He's like, well, somebody came by and told me. Right? So they just walked in, they looked around, yeah, you need a 2-ton. Well, I mean, I told the guy on the phone, and I don't think he was very happy with me. I said, look, we'll do a load calculation. It costs about $300, not a big deal. And he didn't seem too happy with me. He's like, but I already know I need a 2-ton. I said, no, you don't. You don't know. Neither do I. Yeah. Neither does the guy that came by and looked at the salon. I mean, yes, with ductless, we have modulation now that will get us where we need to go. But what if he needs more than a 2-ton?
Exactly.
Hair dryers going, the sun coming through the windows, people. He might have needed a 3-ton or a 4-ton, right? So I'm not putting in a 2-ton, getting a call in the middle of the summer that it's too hot in your daughter's hair studio. So we're going to do this properly.
Exactly, and I think that's the biggest thing. Is I think what I said earlier was about like so much information out there that gentleman made the assumption, hey, this is what I need, but making sure you're going there, doing your calculations, actually taking the time and seeing what the foot traffic is, because who knows, he could have leaky windows as well too. He might even need a 4-ton. You never know. Depends on how many rooms are there. So.
Exactly. So going to load calculations, Nick, do you feel that's important? Like, I mean, we just talked about it. Oversized equipment, undersized ductwork. We need to take a better approach to this.
Yeah, no, I think that every application, again, has a design day condition, right? And so if you sell somebody on a 4-ton and they need a 2-ton, that's just you not doing your part as a technician, right?
Yeah.
Or a 3-ton or something like that.
Exactly.
Making sure that the occupancy comfort level is where it needs to be. I mean, it's all part of that equation.
Yeah. And something Gerry talks about in his training course is know the capacity of what you're putting in. I mean, because if you put in something bigger than you're supposed to, it's more expensive. You may not get the job, and I know that you've preached that in your classes.
It all starts with getting the job, right? This is all caca if we can't get the job.
That's right. Yeah.
But something I preached about my own equipment is stop looking at our model numbers, because they are not representative of what that product can actually do. You are not locked into 24, 36, 42,000 BTUs. And inverter systems have a very generous range of capacity. So look at our capacity tables, not our model numbers. Right. People, I think the biggest problem, Gary, is people try to apply old school unitary knowledge to new heat pumps, to inverter-based equipment, and it just don't fly. It just don't work anymore.
True. Well, just as tools are getting smarter, it's like the manufacturers and making sure that they are sizing these systems, right, or developing these systems and putting that documentation out there for the engineering firms or even the technician that cannot afford to get an engineering firm because their customer can't afford it. They want to make sure they're doing it right. So trying to make sure, as Gerry mentioned, that's a pretty good price to make sure that you get it right the first time and that that's their right. house is efficient.
Yeah. And there's no callbacks. There's no issues down the road that's going to cost even more money, right?
And you mentioned heat gain, heat loss calculations. Let's just go back to that just for a moment if we can. So basic, right? To me, that's where every professional job should start. If you want to be a professional, if you want to be treated like professionals, you got to act like a professional. And putting some science to the sizing starts with a F280 or in the States an ACA Manual J. And come on, there's no excuse for it to not do it anymore. There's software. There's engineers who will be glad to do it for you.
It's inexpensive. It's literally
$250,
$300 to get it done. That's what I pay for it. So
And without it, you're guessing.
That's
I
right.
don't care how good you think you are, how long you've been around, you're guessing.
yeah, perfect.
I think we're past the days of guessing anymore.
Yeah. Awesome. Okay, guys, we're gonna wrap this up. Thank you very much for getting on here. Great conversation.
Thank you, brother.
guys. Thank you.
Thank you, Gary.
Thank you.
Actually, does anybody have any questions before we go? Anybody? He can talk to you about it. Cool. Thanks, guys.
Awesome. Thank you.